Okay, we want to control this motor right here, and it's just a small motor with a gear train on it. I'm going to hook it up to a 9-volt battery. Want to control that using an Arduino, and so we're going to look at what you need to do to make that happen. For one thing, you cannot drive the motor directly from the Arduino. We have to use an intermediate switching device to do that, and the device we're going to use is a MOSFET, an N-channel MOSFET, a 2N7000. First thing you're going to want to do when you go to use a device like this is you want to look at the specification sheet, and so the device itself is right here, and the pinout on the device, this one's actually showing the device turned around, and it's showing us our pins here. I'm going to spread these pins out, and so with the device pointed down, the pinout is source, gate, drain if we flip it around. So I usually like to have a drawing where the flat side is facing me, and if we do that, it's source, gate, drain. So I've got a little drawing here. This is what we're going to wire up, and this is the symbol for the MOSFET. The gate is going to go to pin 3. The reason we're using pin 3 here is pin 3 is a PWM output on the Arduino. The PWM outputs are the ones that all have the little tilde next to them, the little wiggly line next to them. Those are all PWM outputs. So we're going to use number 3, and we're going to apply our signal to the gate. We're going to hook our drain of the device to the motor, which is going to go to our positive terminal of our battery. And I originally was going to make this for a 12-volt system, which it could be run on, but we'll just use a 9-volt battery for now to make things a little bit more portable. The source of the MOSFET is going to go to ground, and the ground of the Arduino and this separate system have to be common. That allows us to drive the MOSFET. We have to have a complete circuit, and we do. We're driving the gate, but we have to drive a signal between the gate and the source, so the source has to be connected to the common of the Arduino, and we're controlling a current between the source, the drain, the motor, and the 9-volt battery. So this is what we're shooting for. Since we're going to run the Arduino off of the USB, we don't really need to hook up the positive 5 volts, but for the ground, we're going to have to take our ground and jump her over from the ground on the Arduino to ground on our board. We're going to make this part of our board ground, and that takes care of this connection right here. Well, not yet, but it takes care of the connection up to this point, because we're going to take the source of our device and also hook it to ground. So I'm going to use another green wire to do that so we can kind of follow the color code here. So there's my source. Remember, looking at the device, the pinout was source gate drain if you flip the device over facing you. So pin 1 is the source, pin number 2 is the gate, and pin number 3 is the drain. So pin 1 is our source. I've got that hooked to ground. Actually, I don't have it hooked to ground yet. It's right there. So now it's hooked to ground. So that takes care of the connection from our source to the Arduino ground. The next thing we want to do is hook up pin 3 of the Arduino, which is going to be the pin we drive it with. We're going to take pin 3 and we're going to hook it to the gate. So I've left a little bit of space behind the transistor to hook up the gate. So pin number 2 on the device here is hooked to the gate of the Arduino. That takes care of this connection right here. Now we're going to take our motor from the drain of the device. Okay, so the drain is going to we're going to hook it to our motor, and I just happen to have, the motor happens to have a nice little plug-in capability, so that makes things a little easier. The other side of the motor is going to go to the positive side of our power supply. I'm going to take the battery off temporarily here. So we've hooked the drain to the motor down here. We've hooked the other side of the motor to V+ on our 9-volt battery. The only thing left to do is to hook the negative terminal of our battery to our ground that we set up, our common. Common and ground are pretty much used interchangeably in electronics here. So that takes care of this connection here between the negative side of the 9-volt battery and this common ground. It's common because we have these 3 connections: the MOSFET source, the ground from the Arduino, and the negative part of the 9-volt battery, all going to this common point. We need that to make this function. Now, the first thing you're going to want to do to test something like this is just write some simple code for it. So I'm going to write a very simple piece of code for this. Okay, I wrote some code here, and basically what I did is I just took the Blink program and I modified it. The LED equals 3 command, I just changed that from 13, what it was before, to 3, because we're driving this through PWM port 3. In the setup, we still have pin mode LED output. In the loop, I've taken out the digital writes and replaced them with one analog write, because this is a command we have to use for PWM. We're doing an analog write, which means we're writing a number from 0 to 255, 255 being the highest and 0 being the lowest. 255 means that the motor is essentially on all the time, and 0 means it would be off. So this analog write command actually means we're writing to pin 3, and we're writing a value of 255, which means that the pulse is most of the time on. It's essentially 100% on, versus if we made it 0 being 0% on. Running the code, downloading the code this way, so I'm going to hit download. You can see the code downloading, or uploading actually, to the Arduino. Okay, so running the code for 255, I get the motor spinning like this. It's good to find something to put the motor in so it's upright and it doesn't sort of roll around on the table. So this is the speed for 255. Now we're going to change the code to another number. Okay, so now I'm changing the number to a lower number, and I found that if you run it less than about 80, the motor has a hard time getting started. There's too little power going to it. So we're going to run it at 80, change the number down to 80, and see what happens here. I'm going to download this code. And you'll probably hear the motor slowing down, and I'll pan over to it here when we get done doing this. So now it's running quite a bit slower. So here's the motor running at a PWM value of 80. Now, once you've got something like this written, some simple code to test it, it opens the door for all kinds of possibilities. You can make the speed vary up and down. You could use the fade command, the fade LED command, to make the motor speed up and slow down automatically. Another thing you can do with this is use an analog input to control the speed of the motor. So if you were to take a input signal from a potentiometer, for instance, and you could vary that voltage from the potentiometer between 0 and 5 volts, then you could drive the motor from minimum speed to maximum speed. What you have to keep in mind though when you do an analog read is analog read signals vary between 0 and 1023, but the analog write command goes from 0 to 255. So you have to scale down the input reading from your analog input to fit into a analog write command. So usually if you divide that by 4, that'll give you what you need to make that work. So I'll leave it to everybody to figure out some more things they can do with this.